I mean, there is a view that materialism isn't really a commitment to any given ontology, right? It's just more of a name we give to a commitment to the scientific process in general. If you think of how we understand matter, right? That's radically changed over time. So, Aristotelians understood the physical world as being kind of matter plus form, and a form was a real thing conjoined with matter to give it the particular properties that it has. And things had kind of an intrinsic teleology. They were directed towards particular ends. And all this kind of changed, again, with people like Descartes. With what happened was you got these mathematical ways of representing the world became available. So things like Cartesian geometry. And you started to represent matter purely in terms of size, shape, position in space, right? Because that's what you can represent about the material world using Cartesian coordinates, right? Using Cartesian geometry. And so what that did was that encouraged a particular view of matter, which was completely different to the Aristotelian view. So you had this kind of ontological revolution. So because you don't represent things like form, you don't represent things like teleology, like matter having particular goals, you just represent size, shape, position, and space. The idea becomes widespread that that's all there is to matter. Of course, that broad idea is what sets up a lot of philosophical questions that we're still mulling over today. Because if you understand matter that way, it becomes a puzzle about how mind could arise from matter. Right? How could mental states, things like first-person experiences, a taste of coffee, what yellowness looks like from a first-person point of view, these things become mysterious because you can't explain them in terms of bits of matter with particular shapes and sizes coming into contact with each other. And then you have another change again, right, from Descartes to Newton. So Descartes had a mechanistic view of matter in the strict sense, right? Causation happened when two bits of matter came into contact with each other and pushed each other in particular ways. Then with Newton, you have things like Newton's gravitational law, which looks like it allows for action at a distance. It says that the sun can exert a gravitational pull on the earth, and it does this without any intervening matter, and it does this instantaneously. Now that's a very different view of matter. Again, I mean, Newton himself sort of prescinded from those metaphysical debates, right? He kind of thought maybe there was some sort of mechanism, something somehow between the sun and the earth that allowed this to happen, but didn't think it was a scientist's job to figure out what it was. He thought it was a scientist's job to provide laws which described how things behaved. But you get this new view of matter where something else comes into the picture, which are these sort of powers, like gravitational forces that matter can exert on each other. And you get this, and this becomes how we understand matter, this becomes how we explain things physically, as you get things like Coulomb's law, which is to do with how charged particles interact with each other. It has exactly the same form as Newton's gravitational law. And the idea is that charge, here's a force, right, where that material objects can exert on each other. But then you get these other complete revolutions in our understanding of matter after that. So things like field theory, right? So understanding magnetic fields, electromagnetic fields. What you have there are vector fields, where you have these mathematical descriptions which will describe how things will behave, but there's no sense of what the physical substrate of a field is. And if you speak to some physicists today, you say, what is a field? They say, well, we don't really know, right? But we have these mathematical descriptions, and they work and they make accurate predictions. So here we have a sense of matter where matter itself seems to fall out of the picture altogether. We don't know what the material substrate of a field is, but scientists were still kind of happy to theorize in that way. And so matter, our sort of ontological understanding of matter, undergoes all these complete changes. What matter is not a kind of fixed target. It changes depending on what theories are current. Of course, like quantum mechanics, the same thing happens again, right? We have to understand matter in very different ways. It's not even clear that we do understand the kind of the material processes or the physical processes which underlie the experimental results and the mathematical formalism we have that allows us to make those kinds of predictions. So there's a sense in which, so you're wondering, is this still science when we're not locked into a particular view of matter? It seems like that's already what's been happening, right? Scientists aren't locked into any particular ontology of matter. They will change the ontology to fit with the best scientific theories, the best scientific models of the time. And so it seems, this kind of approach seems right to me. It seems that scientists shouldn't be locked into any particular ontological understanding of matter. They should be fallibilists about that and willing to revise our understanding of what the physical world is like, if doing so allows us to theorize about the physical world in fruitful ways and make accurate predictions. So all that stuff, I think, should be on the table. Any sort of different view of matter, of what kind of world a scientific theory could describe, that should be up for grabs. So I suppose my answer is yes, it does seem to be like a legitimate scientific approach, because it's what's already happened throughout the history of science.